Alright, this one says determine the values of x for which the function f of x is equal to 2 over x squared minus 4x is continuous. If the function is not continuous, determine the reason. Alright, what we want to find out is where is the function continuous or not continuous. Let's see, let's get a better color here. Where is the function continuous or not continuous? Is the function continuous at x equals 4, x equals 0 and x equals 4? The whole point is basically where are the asymptotes, or at least the vertical asymptotes, where the function would be disrupted or non-continuous. Alright, so at 0, the function is x squared, so it's what? 0 squared minus 4 times 0. You don't really need to know the numerator, but there's no x up there anyway, so it's 0 minus 0, and you can't divide by 0, right? So this one is not continuous. The function is continuous for all values of x less than 0. Well, that's not right, because all values less than x, all values of x less than 2. Well, that's not right, because 0 is less than 2, and it's not continuous there. We just found that out. The function is continuous for all values of x between 0 and 2. Well, if you include 0, then no, it's not. And let's try 3. Let's see if it's outside of this boundary anyway. So we could do, let's see, 2 over 3 squared minus 4 times 3. And so we get 9 minus 12, and that's negative 3. And so, oops, that's over 2. So this is over 2, so it's negative 2/3. So that's not 0, that's a real number. Just y is negative 2/3. So it's continuous past 2. So that's not right. So we know that one's not right, we know this one's not right. The function is not continuous at x. Well, we found out it's also not continuous at 4, although we didn't try that out. Let's go ahead and do that. Let's see, 2 over 4 squared minus 4 times 4, which is the same thing. That's going to give us 16 minus 16, that's 0. That's also undefined. So, defined. So we know for certain now that it's not continuous at 4 either, so that's not an entirely complete definition. The function is continuous for all values of x greater than 0. Well, it's not value at 4, positive 4, so that's not true. The function is not continuous at 4, we know that, but that's not complete enough, because it's not continuous at 0 either. The function is not continuous for all values of x. Well, it's continuous on 2, we just found that out, so that's not true, right? Or 3, whatever. 3, we found that it's continuous there, so... Oh, okay. Oh, it says it's continuous for all values of x. Well, it's not. It's just not continuous for 0 and 4. So let's go ahead and cross those out. The function is not continuous at 2. We'll see 2 times 2 over 2 times 2. It doesn't really matter because it's not continuous at 0 and 4, and that's not complete enough, but we can try out just to make sure we know we get enough practice. So that's 4 minus 8, so that's negative 4 over 2, so that's negative 1/2. So that's continuous there. So that's not true. Why is the function continuous or not continuous? And then you're basically just explaining this, I guess. Why is the function continuous or not continuous? The function does not exist at the point x equals 2. Well, it does exist. We just did that. So that's not true. The function exists for all points, and any small changes in x produces only a small change in f of x. Well, it doesn't exist for all points, so we know that's not true. The function exists for all points, that's not true. The function does not exist at the points x is equal to 0 and x equals 4, and a small change near these values of x may produce large changes in x. I think that's getting more to the point, so I'm going to go ahead and check that one. If we took 3, right, we get 2/3. if we take, oh, these are pretty close. 2, we get negative 1/2. If we were to take 1, we get 1 squared minus 4 times 1. So that's 2 over 1 minus 4 is 3. So we get 2/3. Is that right? It's 3 2/3. Yeah, okay. So there's 1. Okay, and we have 3. We have 2. If we were to take, we could take 5. We take 5. Let's see if that's, I mean, that's close to 4, but 4 we've already found out, I think, yeah. Oh, 4 doesn't work, we know that, that's right. So if we did 2 times, 5 squared minus 4 times 5, that equals 2 over 25 minus 20, and that's equal to 2 over 5, so that's a small change in x, I mean a small change in y for, may produce large, small change near x may produce, of values of x may produce large changes in f of x. Well, I guess if we use like 10, or I guess that maybe that is the large change, 2/5, as opposed to if we use 5, unless we use 3, we get negative 2/3. I really like that question. The function does not exist at the point x equals 0, and a small change in this value may produce large change in x. Alright, so at least we know what they're looking for, but it also doesn't, the function doesn't also not exist at 4. So we're going to have to cancel these out. So we're going to say this one, and that one. The function is not continuous at x is 0 and 4. And that's it for the first one.